Hiya! So welcome to this video for week 6. Today we're going to be talking about standardization. So before we kind of start, we're going to look at one thing that we kind of didn't do in the last video. And that was, so remember how we had the expected value? Something like this, right? How does this correlate into a kind of standard deviation and variance perspective? So if I look at the variance of ax plus b, what we're going to end up having is, well, I'll first have to do ax plus b squared minus e of ax plus b squared, right? So here, this kind of becomes nasty, but it's not too bad, right? So we have a squared x squared plus 2abx plus b squared minus, here we can break this up into the little components, right? So eax plus b, and we're going to square that. Then we get a squared e of x squared, right? Plus 2ab, and then the variable, and then we have b squared left over. And then here we have minus a squared ex squared. Then we get plus 2abe of x plus b squared, right? This part should be okay. And then here we'll have some cancellation, right? So this b squared and this b squared will cancel. This 2abex and this 2abex will cancel. And then I can bring out this a squared to the front. And I'm left with a squared e of x squared minus e of x squared. So this is just a squared times the variance of x. So for the variance case, this is super nice and easy. So this is a nice formula to also keep in mind. And then we can also do a very similar thing for standard deviation, right? Since we have the variance done, right? So this is square root of variance of ax plus b. For variance, remember, we just forget the constant and we square the things in front. So we get a squared variance of x. This a squared, when we pull in front, remember, we don't know what this a is, whether it's positive or minus. So we'll need to do the square, the absolute value, and then square, and then here we would basically just have the standard deviation of x. So that's kind of a nice little thing to work with. The reason why we're doing the absolute value here and not a complex number or something is because in probability, we're only ever working with, we don't really work with complex numbers in this class. So for now, we're just going to stick to this formula. Okay, so what we're going to do is we're going to use these formulas to actually construct what's called a standardized version of expected value and standard deviation. And basically the idea is to kind of make it so the expected value is always at 0 and that the standard deviation doesn't deviate at all. So in order to do this, what we do is we're going to use a certain formula, which at this point should start looking fairly familiar. The formula we're going to be looking at is this. We're going to let x be equal to x minus the expected value divided by the standard deviation. And the reason this should look familiar is because in the binomial case, we get x minus np over the square root of np1 minus p. And this you should recall as x minus mu over sigma. So this is really kind of the idea here, to standardize everything in this way. So what happens when we take the expected value in the standard deviation? So expected value, we saw what we do is, okay, so let me first plug this in. And I'm going to split this minus sign. So I'll have x over sd of x minus e of x over sd of x. So this right-hand side is a constant, right? These are just numbers. So I can just pull that out. And then the bottom part is a constant as well, right? So these are constants. Constants. And so we have this, which is nice. We just get 0. So it doesn't matter what your random variable is. This standardized version, this x star, will always, always, always give me 0. How about the standard deviation? What happens in this case? So here we have standard deviation of, and I'll do the same thing, x minus x over sd of x minus e of x over sd of x. Now this constant part, remember, has to just disappears. So what we're left with is x d of x, and this bottom part comes out, right? So here we have the absolute value of sd of x. Now the sd of x is always positive. So in other words, this is always just going to give us 1. So the standard deviation, well, and in particular the variance as well, is just equal to 1, which is nice. Like it's pretty cool. And so this x star is basically called the standard units. So these are called the standard units for the distribution x. And like I said, this should look very, very familiar, right? This is just, so here I already did mu and sigma for you. So here we end up getting x minus mu over sigma. And this should definitely remind you of normal approximation. Because that's kind of where the niceness in this falls. So we'll stop here. And in the next video, I'll give an example of standardization to kind of break this video up into 2. So I will see you then.